Section 2.5 is about being able to solve an equation for a particular variable. And this is most useful when we're working with formulas. If we can do that, solve the formula for any of its variables, then if we have a formula with multiple variables in it, we can just memorize one formula, and then we can rearrange it to solve for any of the variables in that formula, in effect giving us multiple formulas where we've only actually memorized one. This comes up in electronics, and the first formula you get is Ohm's law, which is V equals I times R, which is the voltage equals current times rate. Well, that's great if I'm given current times resistance. That's great if I'm given current times resistance and I want to find voltage. But what if I'm given voltage and resistance and I need to find current? Then I need to have current I in terms of V, voltage, and resistance. Or if I'm given voltage and current and I want to find resistance, then I need to find resistance R in terms of voltage and current. So, but instead of having to memorize all three of these, I can just memorize the first one and solve for the others when I need them. And after a while you end up with so many formulas in electronics that you don't want to spare the space to write out all three of those for your formula sheet. You want to keep it condensed. In healthcare, we run into several formulas that we rearrange, particularly when dealing with the flow rates, drip rates, infusion times. All that can be rearranged to solve for different things. And even Celsius in terms of Fahrenheit, or Fahrenheit in terms of Celsius. It's the same relationship, it's just a matter of which way you arrange it as to who in terms of whether it's Celsius in terms of Fahrenheit or Fahrenheit in terms of Celsius. So we need to learn to rearrange equations to solve for a particular variable in terms of everything else in that relationship. And the better you are at working with equations, the easier it is. To start out with, it can be a little bit difficult. And so, one thing you can do is you can create a guiding equation to guide you through the operations you need to do with your actual equation to get to solve it for the variable you want. And so, for instance, if we want to solve, this is area equals length times width, and we want to solve it for width. So I need to rearrange this formula so it's width equals whatever in terms of area and length. So what I can do is I can pick some arbitrary numbers just off the top of my head in place of my area and my length, in place of the variables I'm not solving for. Now I like to choose prime numbers because then I don't have reduction issues. So I just arbitrarily said, well, we'll let A equal 3 and L equal 5. Could use any numbers, I like to use small primes myself. And so I then substitute, where there's an A, I put the 3. Here. Where there's an L, I put 5. There. So now I'm creating, that's my guide problem. My actual problem is A equals L times W. So with my guide problem, if I wanted to solve for W, I know that, oh, I have to get that coefficient away from W. Coefficients being multiplied by W. The opposite of multiplication is division, so I'm going to divide both sides of the equation by 5. 5s will divide out, and I'll be left with W equals 3/5, which was garbage in to start with, so it's garbage out. But the point here is that it showed me, oh, here I have to divide both sides by this 5. Well, the 5 is where the L is. So here, that means I must divide both sides by L. Then my L divides out, I'm left with W equals A divided by L. So my guide equation is guiding me through my operations. For our next example, we look at interest equals principal times rate times time. And in this is, in its current form, is written so that you can solve for the interest if you're given the principal, the rate, and the amount of time you're investing. But sometimes we want to try out different scenarios, and we want to know, well, if I have a certain amount of principal, we want to know what the principal would be in terms of interest, the rate, and the time. So we want to solve the equation for P. P equals whatever in terms of the other variables. So I want to create my dummy equation. So for the variables that aren't P, I just arbitrarily substitute some numbers. So I said, well, let I be 7, R I'll make 3, and T I'll make 5. And then I plug those in my equation, and I get this. Now I look at the dummy equation, and so how would I solve that? Oh, well, I know 3 times 5 is 15, but I don't usually write P times 15, I usually write 15 times P. Oh yeah, that looks more familiar. So what did I do? I rearranged my multiplication here. And I actually did a multiplication, but then I rearranged it. So the P was at the end. So I can come over here and I can move P to the end. Because it's all multiplication, we know we can commute multiplication. So we're going to commute that multiplication. Now I can't multiply R and T together because they're just variables right now, I don't have values for them. But I can at least put them in front of the P. So in my dummy equation over here, I'm saying, okay, now I need to get P by itself. So 7 equals 15 times P. I need to get P by itself. I need to get rid of the 15. The 15 is being multiplied by the P, and the opposite of multiplication is division, so I'm going to divide both sides by 15. Okay, I'll need to do the same thing over there. So 15 is where the RT is. So now I need to divide both sides by RT. Here, my 15s will divide out and leave me with P. Here, my RTs will divide out and leave me with P. So now I have P equals I divided by RT. Here I have P equals 7 over 15, but I don't really care because that's just a bunch of dummy numbers in the first place. The point of the dummy numbers is to give you the guide problem. The guide problem's point is to guide me in the operations I need to do to my actual problem. And just as we solved this equation for P, we could also solve it for R, in which case we end up with this. Or we could solve it for T, and we end up with this. But it would all basically work out similarly.